this next session will be I think, a nice wrap up to what we've done today. We'll be talking with Cole Stanton and Chris Anderson specifically about things that you could actually do in buildings to address the contamination in the building areas. So, specific, actual technologies, indoor environmental type treatments that have been used in the past to deal with viral contamination indoors.
When we say buildings, of course, we're talking mainly about homes. We're talking mainly about multifamily buildings, which is something that a lot of us, we've been, the centering around this idea of single family homes, which a lot of America has, but there's a certain classism and, and there's a bunch of stuff loaded into that. So a lot of people and more people are moving into multifamily. So how do we deal with that? And then also we're talking about necessary buildings like grocery stores, like wherever you're going. I mean, what else is open now? This session, we have all white men involved. Last session was all white men. First session, we had 2 women, but it was also all white. So there's going to be a little, the energy is going to be probably a little bit more maleness centered. And that is a limiting perspective. So we definitely do want to continue to have these conversations. And if we hadn't put this together on a dime, which we did in literally the last couple of days, we would have hopefully had a lot more diverse panel of experts. But as it is, you're stuck with us white men on this. So please do forgive us. We did want to make this a more diverse conversation, but it's just not possible, practically speaking, for this week. So we've got this really beautiful bunch of graphs. What we talked about this morning is, and we've got Bob back now, risk, high risk, low risk, doesn't matter. If the people who get this are anywhere close to what they're expecting based on the contagion level, the whole system is going to crash. Not about the death toll. Don't think about how many people are going to die. Think about the fact that we're going to swamp our hospitals. No one's allowed to have cancer. No one's allowed to have babies. No one's allowed to have preemies that require hospitalization either anymore. The whole thing kind of comes crashing now. So that's why we need to flatten this curve, which is what Dr. Sanborn addressed this morning. And that is why we are staying in our houses. I was dubious at first because I was just thinking about death toll and I was thinking, well, are we either crash the economy and it's like, frankly, it's either crash, a few restaurants are going to close. We're going to get used to making our own coffee instead of buying it out of doors. We're going to spend some weeks off work, or the entire civilization comes crashing down because hospitals get completely swamped. Bob, would you like to take over at this point?
So let me introduce our new panelists. For those of you, some of you are just joining us. Some of you have been with us all day, I'm sure. With us, in no particular order, Christopher Anderson. He's a professional engineer and founder and president of KG Anderson, a main consulting and engineering firm since 2002, doing industrial, commercial, healthcare, and residential services, dealing particularly with building energy, HVAC design and diagnostics, envelope design and forensics, retro commissioning, and indoor air quality. Chris is a certified indoor air quality professional and a certified energy manager. And we're really happy to have him on board today. And joining Chris will be Cole Stanton, who is the Director of Education and for the Building Solutions Group of ICP, which is Innovative Chemical Products. Cole's been in the industry forever. Like we're both starting to get pretty old here, my friend. We've been crossing paths for decades now, but he's been involved in more than 30 disaster zones, actually on boots on the ground, right? You've been in 30 disasters since 2003. So, and we met in 2003. So I've actually known you for 17 years.
Wow.
Yeah. Out
Fires,
in
floods, and storms, but
in Los Angeles in that event there in Brockovich. Yeah. Anyway, small world. Also, wingman joining me here is Corbett Lunsford from the PBS television series Home Diagnosis and the Building Performance Workshop.
Proud to be representing for amateurs everywhere. I'm the newest guy in each of these panels, and I really hang on to that with a death grip, because explaining this to normal people is what all of us need to be really good at. So remembering that we all had those dumb questions, really, really important. So feel free to ask dumb questions to that point, by the way. All of
and the thing is, there are no dumb questions, especially we're in an evolving situation here too. So there's, the information that you're receiving on a daily basis is being updated, because really in our lifetimes, we haven't really experienced anything like this, right? This global pandemic would be akin to the Spanish flu of 1918, and that it's really, hitting worldwide, hitting almost every country in the world, right? Every state now in the United States has confirmed cases, and we're just touching on where this is going to end up. So, our third session today is it's titled "Practical Antivirus Measures for Buildings," and both Cole and Chris have a lot of experience in dealing specifically in the built environment and dealing with these type of issues, dealing with contamination, dealing with trying to improve the indoor environmental situations via either chemical treatments and or mechanical ventilation, right? So that's a good preface. I guess let's start off. I'd like to hear, Chris, you have a paper that you published, a white paper, and I'd like to have you just go on a little synopsis of some of the things that, of the thing that you've actually published with the Maine Indoor Air Quality Council.
Sure. I published this really because I deal with primarily commercial properties, and these buildings are all still in operation even today. People are coming into to work to get things done, even though it's a reduced amount of people. They still have to have a functional building that is relatively safe. And so my focus has been, how do we make the buildings safer than what they are with this current environment? And so I published this paper really for my customers to distribute out, and also for contractors, mechanical contractors that I work with here in Maine. And so I distributed it to them as well, with some ideas that they could do to improve the antiviral characteristics of the building. So basically, a lot of the stuff you talked about this morning, you kind of stole a lot of my thunder here. But,
oh dear. That's okay.
So, ventilation is very important, and I do a lot of building investigations, failed buildings, either new or existing buildings, and respond to all sorts of issues. And one of the things I find most frequently done is that the outdoor air dampers have been closed on the HVAC units. These are heating, ventilation, air conditioning systems. And a lot of times this is done in an effort by the mechanical contractor to sort of alleviate thermal comfort complaints in the wintertime. Is really the time that they do that. And then they forget to open the dampers up again come spring. And so the dampers just remain closed all year. And so what I'm telling my customers is have someone go check your outdoor air dampers and make sure that they're opened enough to supply the proper amount of ventilation air into the occupied space. So that's the first thing, is make sure you're actually introducing ventilation air into the building, which is good. That'll also help pressurize the building properly and pressurize the zones the way it supposedly has been designed. And so with that, also, I'm telling them that to increase, if it's set to, let's say, 15% or 20% on the damper, which a lot of times people aren't calculating what the true amount is needed for building. If they can increase that amount, that ventilation amount, then go ahead and increase that, as long as you don't overburden the mechanical system. Increase, because the more ventilation air, the better off you're going to be. The more you dilute the contaminants inside the building. And many studies have been done and proven that as you increase the ventilation air into the building, the cross-contamination between individuals goes down exponentially. So it helps. It definitely helps. And it doesn't hurt to increase it beyond the minimum, the ASHRAE minimum as well. And but at the same time, as you guys discussed in the earlier sessions today, the particulate, the droplets and the nuclei droplets that people are exhaling or coughing or sneezing out into the environment is transmitted and can be transmitted up through the HVAC system, through the ductwork, and then back down into the building again everywhere. So you're basically contaminating every one of the building. And so one of the things with the outdoor air ventilation and the filtration and the unit is that all the outdoor air is supposed to go through a filter. And so I address the issue of filters in my paper. And that is, if you can, Most of the commercial buildings use 2-inch filters. So I tell them, you know, switch over to MERV 13 filters. That'll give you better particulate arrestance. And then, and you're going to experience a pressure drop when you do that. So you have to accommodate the system for that and make sure your system can handle it. And I know Bill Turner's out there listening probably right now. So hi, Bill, you're a great guy. And he addressed that this morning in one of his questions about making sure that the supply fan, you know, is addressed, that you don't, you know, overburden the fan.
And
so,
by the way, one thing about that is that you need to also remember to replace the filters when they get dirty. And in pollen
yes.
season, like now, right? It's like, so there's a you have to be an active participant.
Yeah, and how often do you think should you be replacing filters more readily now in this type of environment, or not? And I know there's a misconception that dirty filters, you know, in fact, actually work better as far as capture.
Well, they do in a way, in that they become more of a resistance to the airflow, and the gaps in the filter tend to close up. So yes, it becomes more of a blockage to the airstream and captures more stuff. But the virus, as you guys talked about, you know, when it lands on surfaces, isn't going to survive, you know, long enough to cause a problem. If you're changing it, at least start now changing them once a quarter, and take a look at them. If they're pretty dirty, increase the frequency, because every building's different. Every environment that the building sits in is different. So you really need to look at the situation.
Would that be your normal frequency you'd recommend anyway? I mean, I'm assuming.
Yes.
Okay, so you're not adopting a new more aggressive frequency of changing.
No, but they can take a look at it. The key that I find, though, with filters is that the filter is only as efficient as the installation of the filter. And so most of the time in these air handling systems, I find air that is bypassing the filter. And it's either due to the manufacturing, which I've got a picture that I sent in a quick slideshow of filters that you can show, where you can see the head of the nut actually holds the frame of the filter off from being actually seated properly, and you get bypass air. So that defeats the whole purpose of the filter. Filters, a lot of times, are just slid into the racks. They don't fit properly. You end up with gaps between filter frames. So I tell them, insist that the filters be taped together to close that gap. Slide the whole thing in, and then make sure the ends are sealed so that you don't have bypass on both ends. And that'll improve your filtering capability and capture some of these particulate. But I also mentioned in there about the particulate, and you guys talked about it in the earlier sessions today too, that the particulate, when it goes out, when it leaves the person and is floating through the air, it's a moist droplet with bacteria, with virus in it, bacteria. You know, who knows what's in there. It's basically a mucus droplet floating through the air, and while it's floating, it's evaporating. So eventually you're going to end up with like a particle with a bunch of virus sitting on this particle. And so you're not really looking at individual viruses necessarily floating in the air. You're looking at a clump. So it's going to be larger typically than just a loose virus floating around. And so a MERV 13 filter, you know, should be adequate to capture quite a bit of that. And we're not talking about turning these buildings into clean rooms, obviously. You can't do that. But what we're doing, and my suggestions in here, is try to do the best you can with what you have to create as clean an environment as possible in your building. And so that's the filters. And then I talk about, let's see, the air handling system, where the outdoor air location is for your air handler. You need to make sure that you're not entraining contaminants into your outdoor airstream into the building. And many times I go into buildings and I inspect the whole thing, and I find that there's sewer vent pipes on the roof that are discharging way too close to the outdoor air intakes. You'll have exhaust fans that are exhausting too close to outdoor air intakes. Sewer vent pipes really should be 30 feet away at least, but then you need to consider the wind direction, eddy currents around the building, that sort of thing, and really make a change in order to take care of that. And a simple change is just taking PVC pipe and extending the vent pipe vertically upward. And I've sent in a picture to you guys showing that on a building that was done a number of years ago, where just about every one of the vent pipes was underneath an outdoor air intake. And we know that the viruses are discharged out of humans in their fecal matter, which gets into the sewer pipes. And Hong Kong, the building that had that big infection with the I think it was a swine flu in that building that infected, over 300 people and killed 30 some odd people in the building, was they traced that down to the virus transmitting through the drain pipes and out of dry traps in the buildings and other places that infected people around the building.
Bob, do we have those pictures, by the way? Can we flash those up?
Scrambling to try to get them.
No problem.
So, yeah.
So with that
Maybe.
said, I also just mentioned that the issue of dry drain traps in the building, to make sure that you do something about the dry drain traps so that doesn't become a conduit for the viruses as well. And
I think that's an interesting point, because any professional who's been in that kind of a situation knows the smell of a dry drain trap. You know what sewer gas smells like. But a normal, civilian who's watching this doesn't necessarily know what that smells like. They don't know that smell when it happens. We can also do things like smell when a water heater is backdrafting. You can smell it, you know what that is. But I think that the informed, the good judgment we were talking about in the last session and informed judgment are different, because you might not know what it means when you sense certain things in your environment.
Yeah, that's exactly right. I actually just notified a building down in New York that I worked on, and I remember I wrote up in the report that they had drain traps. This was like a built-up air handler, 2 large built-up air handlers on the roof. And they had floor drains in the outdoor air intake plenum. And because of snow and water getting into the plenum, they had a place to drain it. But when I went and looked at the traps, there was no water. They were dry, and sewer gas was coming up into the outdoor air intake plenum. And so I told them at that time, you've got to get something in there to seal that. And so I emailed them and notified them, I hope you've gotten those traps sealed, because that's a direct path right in.
Chris, one of the other things you brought up in terms of bypass that we also see is when we're using machines to negatively pressurize ante-rooms and patient rooms to create temporary isolation or auxiliary isolation. We never have enough isolation rooms. And during some of the influenza outbreak concerns in the past, we talked a lot about using portable containment that's negatively pressurized and HEPA filtered to create an airlock and take a room that's normally not an isolation room, but make it function like an isolation room until we can move that patient to capacity, to more permanent built-in isolation. And one of the things that defeats the purpose all the time are, when we're setting up a portable containment outside of a hallway, and I sent Art over to Bob on this, so I'll make him search for that too. These machines are dropped, they're trucked, they're not checked. We really need to be checking our machines when we set them up to make sure we're actually getting HEPA filtration. And that has been an established practice for quite some time with portable machines. So you brought up bypass in a built-in system. It's every bit as important and more of a problem maybe even in the portable machines that we use to create negative pressure and air filtration.
Yes, that's right.
I'd like to point out something real quick just for people. So if you didn't catch on what we talked about, step number 1, practical step, is filtration, filter stuff. But a fine point of this is that one of the things that we're dealing with in this entire series is that we're talking about the side effects of choices. So on the one hand, we're trying to filter out the virus, and that is a good thing. But if the virus is not in your house because you are cleaning with chemicals very heavily, you should know that chemicals are not going to get trapped by this MERV 13 filter, and they will then get disseminated. So if you've cleaned with bleach right next to the return vent on your air handler, that is going to then get distributed, and that new chemistry is going everywhere in the house. The filtration is not going to take that out. So that's, we need to just be aware that the way particles act and the way chemicals act, even if you've got a cap on a bottle of solvent or on a paint can, the chemicals are literally traveling through that metal can to get into your space. And so, being aware of the difference between the chemicals and the particles, particles being where the virus is going to live.
So Corbett, you just provided a really, really good segue into one of the issues that was running through my head the whole time Chris was talking, which is, we want to let everybody know that your HVAC system, the ductwork of your HVAC system, is one place where chemicals, specifically disinfectants and sanitizers, should never be used. There's a lot of discussion in the prior session about everybody trying to sell everybody chemicals right now. And there's certainly a lot of misleading marketing going on. And as the chemical person on the panel, so to speak, I can state, no, we're not all trying to do that. There's a lot of us who are trying to be responsible and serve needs where the needs are appropriate. But one of the places nobody should ever be asking anyone, whether it's residential or commercial or a public building, since 2002, the EPA has been very clear. EPA registered disinfectants and sanitizers are not to be used in the ductwork of HVAC systems, period, full stop.
Thank you.
Awesome. Thank you for
I am so glad you said that.
Well, there's a lot of...
Do you mind if I...
Go ahead, Scott.
First, I apologize. I got called away for a moment and I couldn't get back on time. I apologize, Corbett.
No problem. Go ahead, Scott.
I caught the conversation near the end of the filtration, and I raised this, the previous session, we touched on this a little bit. One of the things we don't know is what is in the air. For the most part, this virus is not free floating. This virus just does not float through the air. It is wrapped up, so to speak, in a little package that comes out of our lungs and out of our mouths. And we talked about that, right? You cough, these big things that land 10 feet away, they do not remain suspended. When we talk, little pieces fly. Even those little pieces of spit, these things that we might call aerosols, if we're an industrial hygienist, they don't stay in the air. They fall. And we keep going back to what are we filtering, why are we wearing the right masks, et cetera, but no one has answered the question, what's really in the air? And there is we don't see the evidence yet at all that suggests that random ambient air carries the virus because someone sick was previously in that space. We don't see the air conveyance system moving contaminated air from one floor to another floor. And if we think through the most common exposure cases where people have gotten sick, they're coughing, they're touching, they're very close. The stuff, if you look at a commercial building, where are the returns? They're almost always on the ceiling, 10 or 12 are very high in the air. So when we cough, that stuff, first of all, only flies 6, 8, maybe 10 feet at the most. It's not going up. It's going down.
That's a dad sneeze. Right. That 10 feet, that's a dad sneeze, by the way.
Those are the particles that are like 100 microns and larger. Anything below that, they can stay suspended, floating.
But we're not seeing that. We're not seeing those small particles. We don't cough those small particles that are posing a risk to people, right? You have to look at where the disease is. When you calculate risk, it's not just, is the virus there? Did people get sick? So
I hear what you're saying. Yeah, just right? To clarify, what our chemist, our atmospheric chemist on the panel that had first thing in the morning said is that these small particles that you exhale when you are literally just breathing or talking are actually able to stay suspended for an hour or two. And I agree with you that we haven't tested for it, but I'd say, just like what Tim was saying in the last session, we need to take responsibility as individuals. Let's just assume that it is possible that just by breathing in the same, within.
All right. Well, then what is possible? 1 chance out of 100 or 1 chance out of 10,000? If it were 1 chance out of 10 or 1 chance out of 100, we would be seeing illness. We would see the illness on the 9th floor of a hospital where we had COVID on the 1st floor, right? Because if it's all the same air conveyance system.
I hear what you're saying. I think
Yeah.
that if we could just stay centered on like practical, things that we
Well,
can
this is
do, and
practical.
also just to remind everybody, a hospital's ventilation system is by no means anything like a multifamily apartment building's ventilation system. So what is happening at hospitals is probably not a very good measure of what could
It's
happen.
similar to but the vast majority of the hospital building is very similar to a commercial office structure.
Sure.
Right.
Well,
When we have special filtration in this hospital, it's in critical zones, right? It's in very special places. It's in the ICU, it's in surgery, it's in research, things like that. It's in pathology, right? So we have to begin to separate those zones out. So the common sense, or the practical, not common because it's not so common, but practical is, do we need to vacate a building 42 stories high if a sick person was on the first floor? And do we need to decontaminate the entire air conveyance system in that building? Practical says, first look at the risk. The risk is that disease is not going to be moved, the virus, to the 42nd floor by the air conveyance system from the 1st to the 42nd, or even from the 40th to the 42nd. So practically, let's stick to what we know about common disease from the lung.
So this discussion does bring up a practical technique which everyone should be aware of in terms of what's called a pull down. So a pull down has a long history. It goes back to some of the earliest days of asbestos abatement, 40 some years, because asbestos fibers that were disturbed could remain airborne for days. So do we need to decontaminate that entire 42-foot building? No. On the other side of the spectrum, if I'm asking specialized cleanup workers to enter a space where I've got reason to believe the hazard level is very high, I could deploy an ultrafine mister or fogger. I could use an airless paint sprayer to generate a fog or mist. I could even use an electrostatic machine because I'm not necessarily worried about long dwell time. What I'm trying to do is get airborne particles, whatever airborne particles, because they all are potential disease vectors, make them heavy by making them wet, allowing gravity to pull them to ground, therefore reducing the risk to my workers I'm sending into that area and making it easier to clean. It's one of those techniques that people can consider. Is it done on every project? No. We have great guidance from CDC in terms of some of the common sense things we should always be doing. Clean from the farthest point back toward your exit to minimize cross-contamination. Clean up high, then down to low to minimize duplicating of efforts and cross-contamination. There's a lot of discussion of, well, do I spray and mist large public areas? And if so, which of the 4 major methods do I use? Foaming, airless, electrostatic, and misting. Or when do I wipe? Do I wipe my touch points first, or do I do it on the way out? Generally, I recommend the latter. These are some of the common sense considerations that we do have a playbook for. We've done this before. We've had bird flu, we've had swine flu, we've had EVD 68, we've had West Nile, and we've had Ebola. So one of the reassuring things we can let everybody know who's watching this is there is a playbook, and there is education available, and there is experience.
And just to tack on that, though, in let's take the multifamily building as an example. People who've got, their grandmother or their mother or themselves living in one of these multifamily buildings, and let's just say 42 feet or 42 stories tall, whatever. If you have, and this is where a lot of us who work in buildings know that what is supposed to happen and what's best practice and what actually happens in real life. If you're a contractor and you've got 5 more jobs to handle today, it's raining, you think you might have coronavirus, you have 5 children that you're trying to put food into, it gets complicated. And so if you have an apartment next to an apartment that is being cleaned like the way that Cole just described, which sounds like a very good, from a chemical standpoint, if your goal is to disinfect, great. But one of the byproducts of this disinfectant that we've been talking about today is that it creates chemistry. So if you are in the apartment next door, I can tell you from blower door testing, and probably many of these guys can as well, that your apartment is connected to that other apartment, most likely. And there might not be the pressure relationship that the mechanical engineers designed in, that they intended to happen between the hallway and the units, might not actually be what's there, which is why Cole was saying you got to test stuff to know. So you should maybe try to induce a positive pressure with using a box fan, something like what Joe was describing earlier, to blow air from outside into your apartment if your next door apartment is being cleaned like that, because you don't want that the travel of the chemistry to go from their apartment into yours. So these are, kind of some of the things that we're trying to just, even though it's a very technical discussion, obviously, we're trying to just wrap our minds around how to have each individual be able to both take care of the community at large and also take care of themselves.
Hey, Corbin, I would tell you that when we use the word like chemistry, I will tell you that one of the good things is that we have a lot of options, right? And Cole and I know each other very well. I know the products and the ingredients, and Cole and I chat about this a lot. One of the fortunate things is that we do have a selection. So I can choose a quat, I can choose a phenol, I can choose a bleach. I can choose a hydrogen peroxide. I can choose fragrance-free. So if I go down that list for what my occupants require for low chemistry, if that is indeed the case, right? Some people want bleach, some people want quats. But if we go down that list, the good thing is we can find fragrance or low VOC type products, and we can find hydrogen peroxide as one of the active ingredients. And we know that hydrogen peroxide is very safe with regard to residual or with regard to this common
Reaction.
What is this big chemical reaction we might be worried about. That's the good thing. So, and by the way, some of those peroxides, we know the peroxides take care of human coronavirus, so that's a good thing. So when we're looking down that list, there's a good chance we can find that. Please, I'm going to stress, and Cole will support me in the other discussion. When we do this, we need to really, as an industry, start talking about cleaning and disinfecting. We must clean first. And what Cole said, the knockdown, he called it a pull down, I call it a knockdown. That is the cleaning stage. We're cleaning particulates out of the air, whether they're a half micron or 10 microns or even 40 microns. We're pulling them out. So that is the cleaning. Then we have to remove that. So we go through our standard cleaning. CDC and OSHA both give us good guidance on how to categorize the risk to our workers. And you might be surprised if you go to OSHA to see where these workers are categorized. When there's no patient involved, when there is not patient care involved, our cleaning and disinfection of general buildings for this disease are going to actually be considered low risk. So it's very interesting to consider that when we're selecting PPE from an industrial hygiene safety point of view. But now I clean, then I can pick all sorts of nice cleaners that have low chemistry and do a very good job because they have surfactants and detergents. Then I can go and decide if I need to disinfect that final surface for whatever reason, and I can make a separate. So it'd be great if we can start to, they have to be done. We have to talk about them both. Cleaning is always necessary.
So I'd like to pitch off to Cole, and actually let's get into the weeds a little on some of the cleaning procedures, and and how you mentioned we've developed the playbooks as an industry at large, dealing with similar or somewhat similar circumstances for cleaning and disinfecting spaces. First of all, where would somebody find that type of guidance, and can you just go through an overview of some of the key points?
Well, that guidance hasn't really been produced in a refined manner by the industry as yet. Everyone is putting together protocols based upon the sources they have available to them. And one of the things that's going to make us a lot stronger coming out of this is we're going to have better protocols. So we're going to be more ready the next time. One consistent element throughout across all the disciplines of restoration is we clean. The fundamental principle is removal of the source, removal of the contaminant. And in this case, those skills, that philosophy are transferable. There are also a lot of things we need to understand about EPA registered disinfectants and sanitizers. And a lot of this was brought up. It was touched upon in the last session, but wasn't really carried through to provide enough understanding to the audience so that it's actionable for them. So I'm hoping we have a little time to do that. One thing that Dr. Krause did say very clearly is if you're looking at a product and it purports to kill virus, then it needs to be registered with the Environmental Protection Agency and registered in the state where it is sold or used. North of the border, it's Health Canada that handles that. So it's a very similar situation up there. Disinfectants and sanitizers, the label is the law. A lot of people want to talk about lists of disinfectants that are out there, lists of disinfectants that are quote unquote approved or effective. Allow me to be very, very clear. You are not, as a manufacturer, able to say that your disinfectant kills the COVID-19 strain of coronavirus. We will not have that strain in the laboratories to develop laboratory methods to determine efficacy, let alone test against those methods for a year, 18 months, 2 years. So one of the things that was mentioned in the prior session was we do a swag, which is a deductive extrapolation of what we feel will kill the new strain. One of the things we look to is products that have an existing human coronavirus strains for prior strains. In other words, there's some rationale and there's strength in the family. If we have some products that have a registration for coronavirus already, then we've got an inkling that they're going to be effective against this strain because they're that similar. But EPA's primary qualification for the list they've created, the so-called list N, of products that could be used. Note, I did not say approved. EPA says, hey, these are products that can be used. I like to let people know it's like Auto Trader. Want a car? Here's a list of cars. We're not telling you if it's a good car. You got to figure that out. But that list is based in large part on whether or not a product can kill some of the really difficult and tenacious viruses, which are generally linked together as small non-enveloped viruses. The best known of which is probably Norovirus, the cruise ship virus. So Norovirus, adenovirus, poliovirus, rotavirus, rhinovirus. EPA's swag, as Dr. Krause put it in the previous session, is if you've got efficacy against those such that you already have the claim on your label, then you are eligible to use that product or be on our list of suggestions for the new strain of coronavirus. So whether you have an existing coronavirus claim and or this claim against these tenacious viruses, you are in a sense pre-qualified. But nobody is approved. EPA hates that word. And no one can say their product is effective against COVID-19 specifically. We won't be able to put that on an EPA label for a very long time.
Specifically though, like again, we've done similar environmental cleaning, and I know Scott's been versed in that. I've been involved in that for the past 30 years. And I know you have, Cole, being actively involved and being out in the field. I mean, you're not just somebody that sits behind a desk. You actually do get out there. I can say that firsthand, that you've even shown up on projects where we had questions in the past. I still think there's going to be people on this webinar right now that don't necessarily even have a grasp on some of the indoor environmental controls that you should be doing on any indoor environmental cleaning project, and obviously something that's an infectious agent. So what are at least some of the key areas that you would think would be germane to this type of a cleanup or cleaning up buildings as a proactive measure?
Sure. Always remember cleaning has to come before disinfectants. In the mold business, we call it clean it, kill it, coat it. In the fire business, we use the same thing. Get rid of the contaminant. Use your chemicals and your coatings at that point as supplementary products. Useful and complementary is a phrase we have in the mold standard, for example. Isolate your HVAC system. Make sure you're not creating cross-contamination problems. Use negative pressure to isolate the work area, and sometimes, when appropriate, use positive pressure to protect your area when you're done. Use products that don't require a rinse because extra moisture leads to mold problems. When you use a concentrate, make sure you understand how long that mixed solution is good for. It may only have a limited lifespan, or it might last as long as 2 months. Look really carefully to make sure that the product is registered on the label for the use site that you're using it in. If it doesn't say you can use it in a cafeteria, you can't use it in a cafeteria. If it doesn't say you can't use it in a home, you can't use it in a home. And those are also based on safety. EPA registers products first and foremost that the product can be used in accordance with the label safely. The fact that the product actually works against the target microorganism is a secondary concern. It's still something EPA evaluates, but it is far secondary to safety. Provide adequate airflow, provide adequate light, provide adequate filtration. And these are all really common sense when you think about it. And they are transferable skills that a lot of the professional restoration contractors who've responded to floods and hurricanes and fires over the years. These are some of the skills that they are taught that they can repurpose for COVID-19. Is it all transferable? No. We do change certain procedures, but a lot of it is, and a lot of the personal protective equipment is. A lot of the disinfectants and sanitizers can also be used for other tasks, like as a laundry additive. But if they can be used that way, it will say so on the label, or it won't. Entryway and exitway sanitizers, shoe baths, the standard cordon sanitaire type practices. These are transferable from what WHO and CDC do out there in the world to even residential projects to maintain, that where we've cleaned stays cleaned, and where it's still dirty, we aren't getting it, making the situation worse.
And obviously the primary focus of this session is commercial buildings and more of a public space type thing. But certainly, what you just mentioned there, how could we maybe distill that into something that the general public, using some of the same mindsets that we, all of us here on this call are all professionals in the industry. We're all well versed with dealing with this type of thing. But John Q. Public is not, at all. What can they do? What can somebody who's just a consumer do to at least adopt some of the best practices and be able to equate it down to a consumer level? Any thoughts? I'd kick that out to everybody, but let you take the first shot.
And by the way, just so Scott, you're muted, by the way.
Now
That's okay. I just want to add something real quick. The reason that we're trying to distinguish between the chemical side, which I agree, Cole has very good points on a lot of stuff, but the one thing that we all can agree on, and that Scott pointed out earlier, is that we do not know what is in the air. And in homes, what you cooked, what you clean with, what kind of lotion you wear on your skin, all has the potential to react to whatever chemical you use to try and disinfect. So don't get too freaky at home with chemical experimentations. That was a big point from Dr. Delphine Carver this morning.
Do not mix chemicals. Do not take EPA registered products and mix them together. Do not create cocktails. All really bad ideas. Use these products in accordance with the label. That is the one thing you absolutely have to do. To answer your question, Bob, to help John Q. Public, as you said, first, we need to work together. We cannot rely on CDC and EPA to give us blow-by-blow guidance on how to use proper chemistry of cleaning or sanitizing or disinfecting. They've already done a lot, and they have better things to do. This is the kind of thing that, those of us who have been involved in indoor air quality for years can pull together and create consensus documents that will help people. We can do more of these types of webinars and make it really accessible. We're in an age where long guidance documents don't get read. We need to understand that and adjust to that reality. And the more we can create modular, accessible, bite-sized pieces of proven knowledge, the better off we're all going to be. And we should be able to do that, not just in this country, but internationally.
But this is a time-sensitive thing here. It's all well and good to say, and I do agree. Looking forward, we need to be able to do this for a long term and be able to distill it. But we also need to distill information now, today.
Hey, Bob, if we distill I've taught a lot of people environmental cleaning. I don't mean workers. I mean the homeowners,
consumers, right?
Who are patients, consumers, right? One at a time. And what I've learned is some simple things. And if we teach them the basics of what we do, it starts with dust control. Dust control is two parts: suppression, don't let it get off the surface into the air, and capture. So capture it if it is in the air, or at least capture and remove it off the surface. If we start with that, we can learn a lot about keeping things clean and how to clean. So we choose those methods and those materials that get rid of that dust while we're cleaning. In this case, we're not just getting rid of dust, we're getting rid of this goop that we brought in our hands that came from somebody's coughing, something like that. So if we follow that, we can choose household cleaners and different types of microfiber cloths and wipes and things like that. And anyone can do that carefully. The other thing is, part of dust suppression is choosing what is going to get in the air. So if I have to choose my priorities to clean, I can't clean everything in my house. There's only one of me. So we clean those surfaces that you're most likely to touch in hospital and disinfection. We call that high frequency touch or touch point type cleaning. So you clean those things you touch, the bedside table, the doorknobs. you don't have to first worry about the top shelf of the bookshelf. That dust is staying where it is. So prioritize your time, prioritize your efforts, and you can begin to get things done to make your step by step, like Cole said, this compartmentalize your cleaning too, and you'll be able to do it much better. And you can think through it and you'll learn. Those are the little things. And then when we talk about chemicals, one of the important things I've learned, took many times to learn this, whatever that person is using already is probably good enough to start with. They bought whatever product they like. They learned they don't react with it. And Corbett and David and Cole, we all say it, we can't stress it enough. Follow the instructions. A lot doesn't mean it works better. Concentrated doesn't mean it works better. And do not mix. We see now more than ever a mix of chemicals that are causing unlivable conditions. They're uninhabitable.
Let's not
three people sprayed 3 things.
You said the word concentrate. I do want people to know that concentrated products are not something to be afraid of. You just have to follow the instructions. And the fact that you can take a product and use it at 2 ounces per gallon or 4 ounces per gallon, and you can get all that yield out of a gallon, is a really productive advantage in a lot of situations. Not a lot of folks have the opportunity to stock 16 gallons of cleaner, for their period of their pandemic, hibernation.
For the consumer.
But I think the key though is that to make sure that that you're following, and this is everybody's just to reiterate, following the manufacturer's instructions on how to handle it, right? Because the problem is people have a tendency sometimes to think, well, if X percentage is good, then if I make it doubly as strong, it's going to work better.
Let me share one thing I teach when I teach on that is I like to teach, and I see Dr. Krause on because this really resonated with me on the earlier session. I like to teach that there's a damage delta. And the damage delta with chemistry on any project is bigger than anything else that's involved, because the cost of obtaining your chemistry and using it properly is actually very small, whether you're a professional restorer or whether you're doing your own work. The cost associated with using it wrong can be the most expensive potential cost you have involved in the project. I mean, we talked about, the great comment about bed bugs, haven't ever killed anybody, but you see entire structures ruined through improper and inadequate or inappropriate treatments. And so nuking a microorganism is a mistake. Follow the label, because the label's based upon kill rates established and shown in the lab, which were then provided as results to EPA, justifying the claim of putting that organism on the label in the first place. And that's why having long organism claim lists are very helpful. To Scott's point, however, also, remember there are also toxicity ratings on these products, usually range from 1 to 4. And some of your category 4 products that also have instructions on them that are really helpful, like safe for children's toys, safe in childcare and daycare areas, botanical. These are the trade-offs. These are the tools. But the fact that a lot of people don't even know they have those choices, that's where this type of informational format is really helpful.
And to help people make the choice, by the way, I'd just like to point out that one of the things that Dr. Farmer talked about this morning is the white paper that she published from the home chem experiment, which is that chlorine-based cleaners create a ton of chemistry that is not great. So if you have an alternative to chlorine, like bleach, somebody's asking about chlorine dioxide, and Cole can tell us what that is if it matters, but essentially anything that is chlorine-based is going to create a lot of chemistry that you just, in a home, just not a good idea. Try and avoid chlorine-based if you can.
So I want to circle back to Chris, because you touched on increasing ventilation, trying to maximize the outside air, and again, this is mostly for commercial buildings. Unfortunately, in residences in the United States, we haven't as yet to see fit to actually have good air changes. I know it's in the current codes, but the vast amount of our residential building stock has little or no outside air except for where it leaks through. So it's usually not coming from great spaces. But to that point, to increasing ventilation, I mean, there's a point of diminishing returns, right? When we're dealing with what the latent removal capacity is in that mechanical equipment. Otherwise we're coming into the warm seasons now where there's going to be higher humidity. So if we dump a bunch of untempered air into a space, aren't we potentially causing other problems?
Oh yeah. Yeah, you have to do it smartly. I mean, you can't just open up the outdoor air damper and let it rip. It really has to be looked at, and you can gradually open it up. But as the as you said, we're coming into warmer, more humid time period. And so you really have to keep an eye on it to make sure that you're not overwhelming the equipment. You can start throwing water off the coil, which can cause mold problems down the line, all sorts of issues. So, yeah.
Bob, this is a good place to point out the nexus of the two conversations you just brought together. There is a time and place for extensive ventilation, and it typically is when you're applying disinfectants or cleaners. So at that, before, during, and immediately after applications of chemicals, especially any kind of bleach product or chlorine-based products, during that period, ventilating the home with everything you got. Opening the windows, turn on the exhaust fans to reduce the applicator's, the homeowner's exposure while it's drying, while it's being used, is usually good practice. Use only in well-ventilated areas. And then afterwards, shut the home back to its normal operating conditions. So, there's a time and a place.
And if that exhaust stream happens to go through filters, change the filters.
Yeah.
Right afterwards.
And also a lot of this stuff is really pertinent for northern climates, but if you're in Florida, if you're in southern Florida right now, actually Florida has incorporated into the code that they're not meeting the same ventilation standards as code as the rest of the country does, because it's so freaky. If you want to be technical, the dew point of the air outside is higher than the indoor temperature almost all the time. So that's, this is where, if you're in Florida, this is, you need to be thinking through some of these things, and obviously consult with experts like these.
Well, the air exchange rates we've seen in homes in Florida and throughout the United States, even in California, new homes is often around 0.05 air changes per hour, just 7 times below the code of 0.35. So, most homes that you especially if it's been built since mid to late 80s, you need to assume is entirely underventilated to achieve any level of safe ventilation. So,
but the question is, can you open a window if you're in Miami? Is it 90 degrees and humid outside or raining?
You may have to. And it's called recovery. After you make your indoors the same as your outdoors, then you need to return to normal operations, maybe use auxiliary dehumidifiers to help remove that humidity over a short period. It's the long-term humidity problems that are an issue. A short-term humidity problem, your bathroom gets that every day, or every time you take a shower.
Yeah,
So,
that's a good point. And that, we're dealing with an epidemic right now that's going to have a certain length to it. So a lot of these recommendations that I'm making, you can back off of these later once we get through this. These are interim measures.
Extraordinary times
to help protect the tenants in the building.
Oh, clearly. So we've got, we're getting toward the end of our allotted time. And again, I suspect we will run a little bit over as we have traditionally throughout the day, but there's, I just want to point out a couple things. All of the PowerPoint presentations that we didn't have the opportunity to get to will all be posted at healthyindoors.com after the event. So Cole and Chris's publications will be there. Also, Chris Anderson's white paper is currently available. His COVID-19 white paper is available on the Maine Indoor Air Quality Council site at maineindoorair.org/resources. You'll be able to find it there. Scott has done a bunch of stuff. Scott has an article currently published in Healthy Indoors. He has another one coming out, right?
There's another one. Yep, it's like 90% done, I promise you. The other thing is I really want to I'm going to make an informal announcement. I'm not authorized to do this, but I'm going to do it anyways. 2 of the large restoration, mitigation, and cleaning organizations have gotten together, and they have issued what is going to be an industry-wide first set of recommendations to those people who provide these services for cleaning and disinfection, the restoration industry. It's going to be very important because it's almost, I don't want to go this far, but it's nearly a landmark agreement because they got together and they agreed.
Yeah. In this industry, that is monumental.
Yes. And so it should be pretty interesting. It's a good document right now. It's very short and sweet and to the point. There'll be follow-ups, but I just want to let people know that that's our first steps in getting sure that we get good services and we have contractors understand what they're providing.
So one of the questions we had from our online audience, is there a test that can be done on a surface to determine if it is clean or uncontaminated? And I'm assuming they're referring to uncontaminated by COVID-19. So
Well, there would be we have two answers to that question. The first is it COVID-19? And the answer is no, we cannot test for COVID-19 in the environment. That is a period, hard stop. Right. Don't let anyone tell you otherwise. It's going to take a long time. Wait, what'd you say, David?
But then the next question is there a surrogate that you can use as an indicator of efficacy?
And that's it. And then, right. And then the surrogate question opens up. I was actually going to split it up into two and say, just answer that directly. And the second was, is there cleaning quality control? Cleaning quality control gets bandied back and forth. And I am always very cautious to open up the door of how we can test for cleaning and cleanability. We do most of the time stick to a visual white glove, black glove. How good does it look, right? There are some people and some who are skilled enough and trained enough to use what we call ATP, but that is only a cleanliness measure. And remember, ATP cannot detect virus. Again, that's
Correct.
A period, hard stop. It's impossible. So don't let anyone tell you they're determining the quantity of the COVID or any virus by using ATP. That's impossible.
No, they're just detecting the organic cleanliness on the surface, basically just the hygiene.
And remember, you don't need to freak out about nuking everything. As already stated, it is not about killing all the microbes and all the viruses and everything. Like, be reasonable.
In terms of killing, because since my company manufactures disinfectants, we get asked this all the time. Well, what assurance do we have? What warranty do you offer? And the answer is disinfection and sanitizing are snapshots in time. It is a valuable, worthwhile thing to do, provided it's accompanied by cleaning and everything else that we've talked about in terms of proper technique. But it is a snapshot in time. The moment you are done, that surface can be recontaminated, theoretically, if someone's sneezing in that room. So, if someone is promising you residual activity from a disinfectant or sanitizer, be exceptionally skeptical and ask to read the label. If it were true, it will be on the label.
I also want to point out the difference between the act of disinfecting and applying a disinfectant and providing a disinfected surface. Many people believe that just by spraying or even wiping on or wiping off a product that says is a disinfectant, it does not mean we've achieved, 100%.
It's not a magic wand.
Right.
Well, a lot of people though, right? We have this thing we call, log 5, log 6 time reduction. In other words, if you have 1 million, we disinfect, there's only 1 left. That is not what the company that is doing is really giving you. They are using products that can achieve that with that product, but the actual use in the field, on the table, on the research lab bench, that doesn't necessarily deliver that.
Right.
That's why quality control of the cleanliness and the application is so important.
And delivery method. This is why delivery method is so important. Early on, I had tons of questions about electrostatic application. And electrostatic is a valuable technique, but the concern is, are we getting surfaces wet enough so that the surface is wet with the antimicrobial for the dwell time that's specified on the label? Because that is very important. And we can actually achieve a better wetting through other techniques, whether it's foaming or whether it's airless paint sprayer with a certain set of settings and a different tip. We can get a surface that is wet, break surface tension, big droplets, and get that 10-minute wet contact time that generally is what we're looking for microorganisms. When we've got things that generate a dry fog, then it's hard to imagine that we're going to get the wet time that's required by the EPA label.
And so just to bring it back to practical applications for Joe Q Public, the two big things that are coming up here is antimicrobial surfaces or antimicrobial actions or disinfectants are number one, that's, you don't want to kill everything. Everything has microbes and all that stuff. So let's be reasonable about cleaning and then disinfecting is two different things. Cleaning, very important. Also remember that as far as your house goes, your space, the space that you are in right now, is a part of the duct system. You are moving air through that. And so if you're trying to clean your ducts and with a filter and, you know, like for the, God forbid, the people who are spraying chemicals inside their ducts, which Cole said, do not do, please. You need to clean your space. You need to be wiping your space. And just as we said in the first thing in the morning, using just simple water and soap is a beautiful thing. So start there, make sure that you're cleaning your space, because as soon as you take an antimicrobial surface, which I have one of right over here, as soon as there's a layer of dust on that, the things are landing on the dust and they're not bothered by the antimicrobial surface underneath. So even if it is long lasting, which God forbid you don't want that, you don't want a lot of chemicals in your space, you need to be cleaning on a regular basis.
We had a comment from the online audience. Again, a possible testing protocol saying, you know, since COVID-19 is a SARS CoV-2 and it's a 96% genome match to SARS, Singapore, it's possible that a SARS PCR test might be okay to use. Maybe it is.
I don't know what would be an acceptable level.
And, well, I'm just wondering how
why would there be the SARS? Why would it be there in the first place, right? Why, if we're going to test for it, that means we're assuming it was there in the beginning.
Right. What's thinking that perhaps the SARS PCR profile, you know, could be a close enough match. I
wouldn't expect it to be.
I wouldn't either. Because DNA is pretty specific. Yeah.
Unique markers.
Yeah, the way the primers work for the analysis is unlikely to do that. We can separate out species really, really well, and whether it's and I don't want to call it a species, but we can separate that out very well with the DNA chemistry. That's unlikely.
So, Chris, I'm going to turn it back to you. Just some final thoughts on what we, you know, again, good practices on the mechanical side. You know, during this situation, because we might be trying to test our mechanical designs further than they were intended originally. And you know, what are your thoughts on, you know, just like a nice summary of what we should be looking at?
Yeah, a couple of things I mentioned in the paper that I didn't get a chance to mention, you know, on screen is the issue of UV lights. And I think that was mentioned this morning. There are some systems that put the lamp in parallel with the airstream that have been proven to be fairly effective. But again, that has to be engineered to make sure that you're getting the exposure time and that the air is moving at the proper rate, you know, passing through that UV area. So that has to be done properly. The other issue is the relative humidity. That they'd shown studies, and I'd mentioned the ASHRAE Tech Hour by Stephanie Taylor when she presented evidence that of studies showing that kind of there's a sweet spot in the relative humidity, 45 to 55% RH was effective, that it actually dropped the infectivity rate by 80%. And so, as Bill mentioned earlier today, you know, you need to use that with caution, particularly in cold climates. Fortunately, we're coming out of winter, or should be, hopefully. We'll be coming out of winter. And so raising the humidity level wouldn't be an issue with the building envelope necessarily. But you'd need to keep an eye on that, you know, and obviously the windows are the kind of the indicator of, am I humidifying too much? You'll start getting condensation. That's kind of your weak place in the building. You know, these things, and actually there's a local store or shop. It's a coffee shop right here in town, and they're still open. And that's where I get lunch. And they're still open. And I pointed out to the owner, I said, this is great because you've got this old brass hardware on the door going in and out. It's a really old building. And I said, I love that old brass hardware because it's so antimicrobial. So I mentioned that, you know, and this has come up in nosocomial infection issues with hospitals and that sort of thing because they've switched over to all the stainless and everything. But in reality, testing has shown that, you know, this old brass is actually fairly low in transmission. So
interesting sidebar there. Let's see, Cole, I'm gonna get you just a final thing here, just because it's mostly your guys' show on this one.
Well, so parting thoughts: clean, clean, clean. Don't over rely on chemistry. And remember, your touch points are where you want to focus your cleaning. If a professional is going to clean a building to establish it back to baseline healthy, don't expect 0 and don't expect 100%. There are no such things. That building should be baseline healthy for what it is, where it is, how it is, and who's going to be in it. Use EPA registered products, recognize the label as the law, and recognize list N for what it is. Look for coronavirus claims on existing prior strains of coronavirus. Look for non-enveloped viruses like rhinovirus, norovirus, and recognize that list N is not all inclusive. And dwell time. Dwell time is really what's critical here. Of all the things we talk about with EPA registered products, we need to make sure these pre-clean surfaces are wet long enough. So look at application methods like foaming and the airless spray application. Those are going to be doing a significantly better job of wetting than some other methods, and they are targeted and controllable, and the applicator can see where they're going to make sure that everything is getting addressed so you get a better result the first time around.
Excellent. David, I'm going to tip it over to you, even though you weren't from this session, but I appreciate Scott and David actually took extra time here to jump in and help participate in session 3. So David, I'll give you the first final thoughts from David Krause. First final thoughts.
If it sounds too good to be true, it is. Okay, this is an emerging issue. Expect charlatans, expect snake oil, expect this will magically fix and prevent and cure. Be very skeptical on everything, and ask for guarantees. if they're guaranteeing it'll get rid of it, and see if it works. But yeah, just have a very high index of suspicion.
Scott.
If it sounds too good to be true, I'm 100% on that. And also, don't mix the chemicals, and vet your contractors and service providers. Make sure they know what they're doing, and insist on quality control. Have them prove they did a good job. Don't worry about the testing. Don't worry about the chemicals. Have them prove they did a good job, and then you'll come out way, way ahead.
And to my co-moderator for the day, Corbett Lunsford, give you a final set of thoughts here today too.
Sure, I think that just talking to the homeowners of all races, of all genders, remember that the home is a system, and no one product, no one chemical, no one technique or approach is going to solve all the stuff that you're going to be seeing and feeling and experiencing and smelling over the next couple of weeks as you're stuck in your house 24 hours a day with your entire family at the same time. Your house was probably not built to do what you're asking it to do right now. Some of us are in cold weather, some of us are in hot weather. Everybody's going to be having different experiences of what's going on. And just remember that there's no silver bullet. As everybody has said, there's silver buckshot, which is you kind of use your way forward is critical thinking. And we've got lots of resources on the YouTube channel, Home Performance, on the Healthy Indoors website, and you can go through all the back issues for free of Healthy Indoors magazine, through the white paper that you can get from Chris, through all the links that we've posted, and those will be posted again on this Healthy Indoors webpage that is on that site. So just remember to be reasonable, think through yourself, try and be an individual, but also be a part of the community, and remember to be voluntary in all of these steps that we're taking.
I'd like to close it out by saying, again, thanking all of you for taking times out of your busy days. I know, we're all kind of in red light crisis mode here. All of us from the indoor environmental medical communities and all the ancillary ones. For Healthy Indoors magazine, we will be publishing our March digital edition in about a week. Obviously, the headline, our feature stories changed radically, so we're putting a bunch of new content in, but we'll be discussing in a lot of this content that we've had thus far today. All of today's sessions have been recorded. They will be available at healthyindoors.com and at Home Diagnosis TV. Is that where you're going? Or
if you just go to the Home Performance YouTube channel,
okay.
and just search Home Performance on YouTube.
Okay, so we'll have them up there as well. We most likely, we haven't planned this yet, but I'm already sitting here for the 8 hours today. Healthy Indoors will definitely be doing another set of sessions next week because I just think this is it's important for us to try to be here and at least try to be a vehicle for getting information out there. And hopefully some of our experts that joined us today will have an opportunity to maybe come back and we can maybe dig deeper, because this is an evolving story. There's no question about it. You know, we're giving you what we know the best of our knowledge today. By 7 days from now, there might be some evolution there, I think. So, so for all of us today, I'm Bob Krell from Healthy Indoors, and I thank you all for attending. I'm sorry we didn't get to everybody's questions, but we will we'll post answers to ones that we can actually answer in a written long form later on the website as well. So, anyway.
Great. Thank you, everybody.
Thanks, everybody.
Thanks, everybody.
Appreciate it.
Thank you.